Okay, so we're looking at finding the value of the derivative at a point and sketching a derivative. And in this particular case, we are looking at a function that you can't differentiate. So this function is a rational function. We've got just way too much happening on that quotient for you to be able to know how to differentiate it. So we can do this on the graphing calculator. Our first thing we're going to do is we're going to add a graph page, which will let us type in the original function, and then we can reference this original function. So I'm going to put up a quotient like this and type in the function as I see it. X squared plus 2 all over 1 plus x. There's my function. You guys following along? Yeah. I'm going to go back to this page here. Now this is an essential routine for us, finding the value of a derivative at a point. We press menu, and of course it's going to be under calculus, number 4. And this first one, the numerical derivative at a point. We have to tell it what the variable is going to be and what the value. So we've got x equals minus 2. So we type in x and we type in minus 2. We press OK. It pulls up a little template for us here.
It's menu?
Menu for what? Menu.
Windows.
Yeah.
Sorry, on the calculator.
On the calculator page. Okay. So here, in this little space, we can type the function as we see it here. We can type the function again, but we're not gonna, because we've already typed the function in. So you just have to press variables and choose the function that we've just typed in and apply it over the domain of x. So you press variables, choose the function that you just typed, f1 in my case, make it f1 of x, and then press enter. And there is the answer. So, y prime of negative 2 is equal to,
I see.
that's null, negative 2. Let's try a different value just to make sure I'm not getting out anything strange. Let's try negative 3. Oops.
So do we type? When you get a type and how do you get a Is this?
All right, so let me show you again. Menu for 1. We type in x. We type in the value that we want. I'm going to go for minus 5 this time. Here, in this little hole, to get the function, we press variables, we press F1, and then we say of x. This will give us our answer.
Let's see. I don't have F1 like this.
Did you type the function into the graph page? I'll check you in a minute. Let me move on to the next one. So, this routine. We wish to sketch the function here. We've got the function sketch. We wish to sketch the derivative. Sophie. Focus on this one. Follow me along. Calculator's down for a second. We want to sketch the derivative. So we press tab. And hopefully it'll stop tabbing backwards and forwards. There we go. We press tab. And we can press this little template button here. And here in this template button, over there you can see d over d something x. So we can choose this template or not. Yes, there we go. We say the derivative with respect to x, and then in here, we put f1 of x again. Like that. So we're saying differentiate f1 of x with respect to x using the template, and it should graph it for us. Sir? Okay.
You take a question? I was going to ask. So for the first question, you know how we just wrote derivative of y equals 2? So in an exam, obviously we use the calculator. How would we get that? Would we get full points for writing that?
That would be enough.
So we don't have to show words. We can just say it on the calculator. Okay.
So here on, sorry, let me finish this question. We're asked to sketch the graph. So our graph looks like this, and our derivative looks like this. Let me just get this right. We're going through there, like this. Okay, so what's important about this graph and how to sketch these ones is you need to make sure when you're doing these sketches that your turning points, your minimum and your maximum points, line up with where the derivative goes through the x-axis, because we need to read these points. So here, let me get my pen so you can follow along in the video as well.
Sir, the graph is like not clear on the paper. Can we just draw a dot to like?
Answer your question. What? Sorry.
For example, for example, the minimum and the x is 0. Can we just draw a dot on the graph?
Yeah. Start by putting it. So what you're saying is to draw this like I've drawn it. Start by putting a dot there to make sure you go through it. Definitely. So go straight up from your minimum or your maximum and put a dot on the x-axis, and then draw your line going through it. Because that's the most important thing to show. Axes intersects are the most important things to show when you're sketching a graph from the calculator. Find where your axes intersects are and plot those, and if necessary, give them a value too by finding them. So
Can you find the thing lines? Or is that?
and these two green lines I'm showing because in order to, if you're given a question, sketch this graph, and we've got a graph that looks like this, what is it that you're having to sketch carefully? And what you're having to sketch carefully is the relationship between the minimum and maximum on that blue curve and where the red curve cuts the x-axis. Because those are the points where the derivative is equal to 0, and they should line up. So when a function has a minimum, like here somewhere near 1-ish, then the derivative should cut the x-axis at that point. We should get used to reading the derivative graph to be able to say which one is a maximum and which one is a minimum. If we take now this point here has a positive value of the derivative because we're above the x-axis, a 0 value, and then a negative value. So the graph here goes positive, 0, negative, just in its value. And the derivative has a line going up here, which would be a positive gradient, a line going across here, which would be a 0 gradient, and a line going down here, which would be a negative gradient. So there on that red curve, you can read the original function will have a maximum somewhere here on this green line. We don't know where on the green line. You can never tell. Just by reading the derivative, you can never tell where on the green line that maximum is going to be, but you know there's a maximum there. We have the same situation here on the right-hand side. We have this coming down, which means negative, this going across, which means 0, and this going up, which means positive. This is a negative value because it's below the x-axis. Here it's a 0 value because it's on the x-axis, and here it's a positive value. So you get these two little sign tables. So when you get plus 0 minus, this is a maximum point. And when you get minus 0 plus, this is a minimum point. And the way that you can figure it out is with positive, it goes up. With 0, it goes across, and with negative, it goes down. And it kind of sketches a maximum.
Where's the 0 point for the?
When it goes negative, it goes down. 0, it goes across. Positive, it goes up. And that creates a minimum